All right, so when you have a quadratic, okay, we factored yesterday, and by factoring we found our roots. Okay, so let's just recall quick. If I gave you something like this, and we factored, and we solved it, x equals -2, because -2 plus 2 is 0. X equals -1, because -1 plus 1 is 0. That is where I'm crossing the x-axis at -2 and -1. Those are my roots, okay? We can factor and solve to find the roots. But here's the big dilemma. What if I have a quadratic that's not factorable? Right? What do I multiply equals -7 but add equals 2? There is nothing. What do I multiply equals -1 but add equals 10? Can't do it. Okay? So we know that if I have two important parts of a quadratic, the two most important parts of a quadratic is its vertex, the minimum and maximum, and we spent the first half of this chapter looking at the minimum maximum. The second important thing is these roots here, okay? So what we know is that if I have vertex form, oops, we'll do something like that, right? If I have vertex form, this is great because I know I moved right 2 down 20. I can tell just by looking at it what my vertex is, right? Vertex is 2, -20. Then, the also great thing about vertex form is I can set this equal to 0 and solve for my roots. I can add 20 on both sides and then have x minus 2 squared equals 20. Get rid of the squared by square rooting both sides. That gets rid of that. I get x minus 2 equals 2 root 5 plus or minus. Add the 2. And I get 2 plus or minus 2 root 5. So they're not nice roots because if it was to be nice roots, that would have been factorable. Whenever it's not factorable, I'm going to have some irrational roots. Okay, so that's why vertex form is so nice because I can see just how it moved left and right, up and down, stretch the compressions. I can say just by looking at it what the vertex is. And then just a couple more steps, I can solve it to find my roots. Okay. So the big question in mathematics was, well, can I get a standard form quadratic into vertex form? Because if I can put this into vertex form, I can tell you all the important properties of that quadratic. That's what we're doing today. That's called completing the square, putting standard form into vertex form. But here's the big question I'm sure you have. Ms. Chapman, how did you get from here to here? How did square root of 20 become 2 square root of 5? So we kind of have to recall how to simplify radicals. So let's review. So time out, right? Before to go on, we need to remember how to review radicals. I know you did it because Pythagorean theorem, you had to reduce radicals somewhere, okay? And this is how it works. Square root of 36 is what? 6. Because 6 times 6 is 36. Square root means 2 of something, you take 1 out. Because really this is a radical sign, but we call it a square root because there's really a little 2 there. But we don't write the 2 because the most commonly used radical is a square root. Later, next semester, we're going to do cubed root, we're going to do 4th root, we're going to do 5th root, and so on when we study radical functions. Okay? But this is just square root. It means if I have 2 of something, it comes out. So when I had that square root of 20, okay, I could picture in my head that 20 is 5 times 4, and 4 is 2 times 2. Break it down into primes. Do I have 2 of something? I have 2 2's. That's going to come out. 5 doesn't have a partner, so it stays. So your rule is if there's 2 of something, you take 1 out. Okay, let's try another one. How about square root of 8? break down square root of 8. 8 is 4 and 2, and 4 is 2 and 2. Do I have pairs of anything? I have 2 2's, so I can take one out. And this one doesn't have a partner, so it stays. Okay. How about square root of 72? Break down 72. 72 is what? What do you want to do? 8 and 9? Okay, 8 and 9, that's fine. If you want to do 2 and 26, that would have been fine too. It doesn't matter how you break it down, but then you have to keep breaking it down all the way. So notice 8 is, and 4 is, okay, so that's all the way, right? And then 9 is, okay, so what are my pairs? 2 2's, 2 3's, okay, so I'm going to take out a 2, take out a 3. What's left? A 2. Whatever comes out gets multiplied. So if I take a 2 out, take a 3 out, they're going to get multiplied. Whatever stays underneath, if there was more than one thing underneath here, it would also get multiplied. Okay. Try another one. How about the square root of 216? What would you break that into? 2 and 108. That'd be a good one, yep. Because then 108, I can say 2 and 54. Good. And 54, I can say 2 and 27. And 27, I can say 3 and 9. And 9 is, okay. So there's a lot of primes right there. So look for your groups of 2. 2 2's, right? What else? 2 3's. Does this 3 have a partner? Nope. Does this 2 have a partner? Nope. So this 2 and this 3 is going to come out, get multiplied. This 2 and this 3 is going to stay and get multiplied. So it's really going to be 6 square root 6. Okay, the first example I want to do, I want to just do, and I'm not going to do an example on your sheet, I just want you to watch first, and then we'll do 3 examples together. Okay? So you should look at see the steps I have on top of your sheet? Okay, so this is taking standard form, putting it into vertex form so I can find my vertex and my roots. I'm doing 2 things for each problem, finding the vertex and the roots. Okay? So if I follow the steps in my sheet, step 1 says make sure all the terms are on one side and it's set equal to 0. I want the squared term first, then the x term, then the constant. A, B, C. You always want standard form. A is 1, and A is going to be 1 on all of your problems today. Tomorrow we'll worry about when A is not 1. We're take 2 days to do this. So A is 1, good. Step 3 says put spaces behind your B term and your C term. So I'd have x squared minus 6x, put a space, and then put another space. Okay. Now, in those spaces, what I want is that when I had this quadratic, this 2 wouldn't let me factor because I couldn't multiply to equal -2 but add equals -6. I couldn't do it. So what I'm doing is like, okay, you go away because you're not working, right? And let's find a number that will let me factor, okay? And not only factor the quadratic, but factor into something that's vertex form, right? When I have vertex form, I want a binomial squared, meaning I want this quadratic right here, I want some number that's going to allow me to factor into x plus 3, which is x plus 3 squared, or x minus 5, which would be x minus 5 squared. I want it to factor into something I can write as a binomial squared. So some magic number is going to allow me to do that, and I don't have to guess. There's a formula. It's b over 2 squared. B being whatever number's in front of the x term. So -6 divided by 2 squared is -3 squared, which is 9. 9 is going to be the number that allows me to get this into this form. So I'm going to add 9 here. But the thing is, if you add something into the equation, to keep it balanced, you have to subtract it back out. right? You just can't add something in without changing it. If you add it in, you have to subtract it out to keep it balanced. Because now look what happened. If I just look at this quadratic now with the 9, what do I multiply equals 9 but add equals -6? -3, -3. So this now factors into this, which I can write as x minus 3 squared. And that's part of what I want for vertex form. And then to get the k part, you combine your last two terms, which is going to be -11. Ta-da, right? There's standard form into vertex form. And now I can find the two important things. I can say, okay, my vertex is 3, -11, because this means 3 to the right, 11 down. So that's one important part, the vertex. And then I can set it up over here and set it equal to 0 and solve it for my roots. So add 11, square root both sides to get rid of that squared. So it's going to be plus or minus 11, right? Why plus or minus? Because negative squared and positive squared are both positive, so you have to consider both. It's always a plus or minus when you square root. 11 is prime. It's 11 and 1, so there's no 2 of anything, so it doesn't simplify. So my last step would just be to add the 3. Can't combine those are not like terms. This is a nice integer, that's an irrational number. So it would be x equals 3 plus or minus square root 11. Those would be my two roots. So what am I looking at? If I were to graph this parabola, I went 3, -11, and then I'm crossing at 3 plus square root 11. Oh, that'd be minus 3 minus square root 11, 3 plus square root 11, and that would be my two roots where I'm crossing. So I got my roots and my vertex from my vertex form. Okay, so let's follow the steps. All my terms are on one side. A is 1, right? So I'm at this step. Put in the spaces behind my B term and C term. So x squared plus 10x space minus 1 space. What goes in the space? What's my formula? B over 2 squared, right? Which is 10 divided by 2 squared, which is 5 squared, which is 25. So I'm going to add 25 here, but if I add it in, I have to subtract it out. Okay. Why 25? Because now 25, I can take this quadratic and factor it into a binomial squared. Because what do I multiply equals 25 but add equals 10? 5 and 5. So it factors x plus 5, x plus 5, which is x plus 5 squared. I get my binomial squared from that. And then I also need to simplify, find the k, -26, and I have vertex form. So two things you're going to find from this vertex form. The first being, well, what's my vertex? I moved 5 to the left, 26 down, so -5, -26. Right, that's the first part. And then you want to do the second part. You're going to say, okay, now what are my roots? So if I take vertex form and set it equal to 0, I can solve for x to find my roots. So let's see, add 26. Get rid of the squared, so I need to square root both sides. So I get x plus 5 equals, now 26, does that radical reduce down? No, 2 and 13, there's not 2 of anything, so it just stays, plus or minus square root of 26. And then my last step, to get x by itself, I need to subtract the 5. but you cannot combine those like terms. They're not like terms. So x equals negative 5 plus or minus square root of 26. So there's my two roots. That's where it's crossing the x-axis. And here's my vertex. That's my minimum. So again, all my terms are in one side, standard form. A is 1, so let's put it in the spaces. You're going to put a space after the B term, and then a space after the C term. Okay? So you're going to find the number that lets me factor. So to get that number, we do B divided by 2 squared, which is 2 divided by 2 squared, which is 1 squared, which is 1. So my first blank, I add the 1. My second blank, I subtract the 1. If you add it in, you got to subtract it out. Now that 1 is going to let me factor. What do I multiply equals 1 but add equals 2? 1 and 1. Right? 1 times 1 is 1. 1 plus 1 is 2, which is x plus 1 squared. And then I need to combine my terms out here. Don't forget about those. Negative 7 minus 1 is negative 8. And then I get vertex form. Standard form became vertex form. And then from here, what are the important parts? Well, my vertex is important. I went 1 to the left, 8 down. And then I can use that vertex form to find my roots by setting it equal to 0. So I would add 8. Square root both sides to get rid of that squared. Now 8, that's going to simplify because 8 is 4 and 2, and 4 is 2 times 2. So there's 2 2's, I can take one out. So I get x plus 1 equals plus or minus 2 root 2. Right? Always plus or minus. And then my last step would be get x by itself, so subtract the 1. So subtract 1, but those are not like terms. So I have negative 1 plus or minus 2 square root 2. This last example, on step 2, it says make sure A is a positive 1. Okay. Now, when I am doing vertex form, these two terms are the one that turn into binomial squared. Right? This becomes part of the k. This part becomes the binomial squared. So when a is not 1, I have to factor out whatever that number is. So in this case, it's a negative 1 I'm going to factor out. So I'm going to factor out a negative from the first 2 terms. Right? Only the first 2 terms, because those are the ones that turn into the binomial squared. Why did it become negative 6? Because if I take out a negative, right, that changes the sign. If I take out a negative, that makes this negative a positive and this positive a negative. Okay, negatives always change signs, whether you put it in or pull it out. I still have the plus 10. Your third step is still the same. You put a space behind the B term. You put a space behind the C term. You're still going to do the same formula. B over 2 squared, which is negative 6 over 2 squared, which is negative 3 squared, which is 9. Okay. Now here's the tricky part. When I put a plus 9 here, what am I going to do out here? Because you got to look. If I'm adding 9 here, but if there's a negative, that means I'm really subtracting 9. See that? So you're not going to subtract 9 out here because this means subtract 9 because of that negative. So I would add 9 out here. Okay, you have to think, if there's something outside the parentheses, you have to think, I'm really subtracting a 9, so I have to add 9. You always do the opposite. Then I can write it as a binomial squared. Keep the negative. What do I multiply equals 9, but add equals negative 6? Negative 3 and negative 3, which I can write as negative 3 squared. Add the last two terms, 19. And then it's vertex form. And then I can do, okay, what's the vertex? This one's going to be a maximum because it opens down. And my vertex is going to be 3, 19, not negative 19, because I went 3 to the right, 19 up. And then I can solve it. So negative x minus 3 squared plus 19 equals 0. Solve for x, I would subtract 19. To get rid of this negative out here, you're multiplying by negative 1. So I would have to divide both sides by negative 1 to get rid of that. So then x minus 3 squared equals a positive 19. Then I can square root both sides, which 19 is prime. That's not going to break down. So x minus 3 equals plus or minus square root 19. And then my last step would be to add the 3. So my roots are x equals 3 plus or minus square root 19.